Hi folks, I welcome you back to Global Education Zone. In this episode, we are going to be dealing with the development of the frustum of the hexagonal prism. So, first off, let's draw the hexagonal prism. So you have to start with your circular base. So I'll draw a circle that represents the base. This is how the base looks. It's drawn on a circle. Then I would draw my choosing horizontal line. So I want this to be my horizontal line. I'll just project it to the rightmost part of the drawing. Then I'll divide it into 6 parts because this is a hexagon. So it has 6 vertices. These are the 6 parts. So then I'll join these vertices together. So then I'll get the hexagon. So this is also the way of drawing a hexagon when given when given the distance between the vertices. But when you are given the distance between the flats, there's a different method for that. So we'll be talking about that in this video, in another video hopefully. Now the next thing to do is to draw the vertical distances. Let's project the vertical distances upwards. So let's project this upwards. Let's project this upwards. Project this upwards. Project this upwards. Yes, good. So now the next thing to do is the let's call it the front elevation of this hexagonal prism. So here we go. Here we go. Good. Now let's draw the truncation. So today, as I told you guys in the 21st episode, this is actually the 22nd episode. Now in the 21st episode, I told that I've been making a convergent process of having to slope my truncation from left to right. So I will now slope it from right to left now this time around, so that you can see that there are many ways of achieving the same result. So I'm sloping it from left to right in the left from right to left in this video. So it's not a must. So if you see in your exam you slope from left to right or from right to left, they are still the same thing. It depends, but the only thing that differs is the points that will be crossed on the development. So now let's project these lines to the right, because my development will be on the right. So I'll project everything to the rightmost part. So this is the base. I'm projecting the base right. Then the center line, I've done that. The top of the plan projected. Then the bottom of the truncation projected. One of the lines of the vertices projected. One of the lines projected. So I'll now extend them, because it's not a long ruler like that. So all the lines have been, okay, not all yet. Not all. Now all the lines have been projected. Now the next thing to do is to draw the development. Now, so let's just count off the radius of the circle to the right. So basically the radius of the circle, you open your compass to the radius of the circle, and then you begin to count it off, the number of times of the side. So we have 6 sides, right? So we'll count it off 6 times to the right. So that will be 1, 2, 3, 4, 5, 6. So these are going to be the 6 sides. Let's number them A, B, C, D, E, and F. So we'll also number them here. A, B. Let's call them yes, just A, B, C, D, E, and F. Then you go back to A. So that's the last episode. I mentioned that that's how you know whether you are correct. So when you are going back to your previous drawing, that shows that you are actually correct. And next thing to do is let's actually begin to know which parts. Let's begin to know which parts we're going to be dealing with. So we have this A, that would be, A would be on this side, so this is the point. Then B, let's project it up, projecting to the right to intersect B. So okay, first of all, I haven't done the vertical height. Let me do that. So I will need the vertical height in order to cross these horizontal projections. So most of the time, drawings in technical drawing are based on the intersection of vertical and horizontal lines. So they intersect based on different conditions. So our drawings are based on these conditions. So that's why I need the vertical lines. So once they intersect, they will satisfy the position. Then we'll have the B. So B is taken from here. So intersect B. We have the C taken vertically. When it causes truncation, we move perpendicular to the original direction. Then we'll get to C. Okay, this is C rather. D, we call it truncation. It's actually at the topmost of the truncation. D. So that's D rather. You have the E, cutting this side. Let's place it. The E. The F, cutting this side again. That's F. Then when we go back to A, it's cutting the lowest part of the truncation, just as we started with. So we have the A, E, F. Okay, F is rather okay. F. Then we have the A. Yes. So good. Now the next thing to do is to join each of these lines to one another. Let's join the first. Let's join the A line to the B line. B line to the B point to the C point. Rather, not line point. C to the D. D to E. So actually this side is, so you can see that this side is actually on this point. So actually, okay, rather this is D to E. D to E. So this is E. This is D to E. Then we have E to F. Then we have F to A. So I will now draw the vertical. I'll take in the vertical lines to show that this is where I'm coming from. So this is taking out the vertical lines. So I haven't done that. The last thing to do is the horizontal line. So this is the development. But before we are done, you also need to draw the base and the top. Now that top will correspond to the true shape. So once you've drawn the true shape, if you don't know how to draw a true shape, you can check out the episode on this course where I talk about how to draw true shapes. But then the base, this is the base. All you need to do is you draw the base again, but you make sure the one of these sides is coinciding with the base of the development. So that's to show that they're actually connected. So you draw the base and then the true shape as the top. So this is how to draw the development of the frustum of the hexagonal prism. Thanks for watching. See you next episode.